Hey everyone, welcome to another Philip in the Cloud. Today we're going to be talking about ibis.read again and how to use it with Apache Parquet. And I've kind of cooked up a little problem that I was curious about, and I'm going to try and kind of solve it live with ibis. And if it doesn't work out, then we'll have found some bugs or some rough edges. Uh, but let's get started. So the question is, for a given actor in our movielens dataset, which you can check out from the last video as well. For a given actor, in what genre have they made the most movies? And I thought about this for a little bit, and I'm thinking about kind of a multi-step process for how to get this done. So step one, we need to do the basics. We need to load our movies. Okay. Step two, we need to get our actors data set. Hopefully there's some way to relate these two things, but there may not be, and we'll need to figure that out. Step three, we need to filter out any additional junk that's in the actors table. Some actors are directors, and some, directors are actors, and so forth. And so the table that contains the information about actors contains information about the kind of the main people involved in a particular movie. So we'll need to filter. We're going to need to filter in the actors. So let's check that out. And then step four, let's see, we need to figure out the genres of all the movies each actor has made. And this is probably going to be the most intricate part if I had to guess. And then step five is sort of the fun part where we can poke around at some actors that I know about and see what the answer is to our original question, which is that. All right, so let's start with step one, which is to load the movies dataset. Now last time I showed we had this dataset in data ml-parquet, which ml means movielens, and I have my movies dataset in here. And of course, we can just verify that it's a Parquet file. Cool. So let's make that into it. Let's import ibis, turn on interactive mode, and pull in the underscore, kind of the standard imports. So let's make a movies dataset, movies table from this Parquet file, read it in, and now we've got our movies. Okay, let's remind ourselves what was step two, load actors. Okay, so let's load our actors. We're going to load this principals tab separated value compressed, gzip compressed text file. We know that any quotes in there are actually embedded in the data itself and not actually delimiting a field. And the null string we know is \n. Now, of course, this is Python, so you can write it like this too. And then you can optionally include this. DuckDB has a fairly smart way of trying to detect this, but I'm just going to put it in there anyway, so it doesn't have to think so hard. All right, so now we've got our actors. We've got a bunch of columns in here, and you can see we've got tconst, which is a join key, nconst, which is the unique identifier, I believe, for the particular person. We've got their job, and so let's look at what other columns we have. Characters. Okay, so we can pull out characters and see if that's of interest to us before moving on. Not particularly interesting, at least the first 10 or so rows. Let's look at a value counts, just to make sure there's nothing super relevant. Hopefully this doesn't crash due to some inputs from the CSV parser that I forgot to include. Okay. Let's see if we can Control C out of this. Looks like maybe not. Okay, great. All right, so let's avoid using the characters column for now. I don't think we'll actually need it again here. Oh, looks like something got futzed up here. All right, let's see if we can recreate that table. Great. So again, we've gotten to step 2. So we've loaded our actors. Now let's remind ourselves what step 3 is. Filter in the actors. So it looks like we only want actors. Let's say actors dot filter where category, use the underscore, dot is in actor and actress. Okay. Okay, it looks like got some stuff going on there. So we filtered in our actors. Now this is probably not enough information yet to move on, but let's see what step 4 is. Figure out genres of all the movies each actor has made. So right now we have movies. Great. Looks like things are misbehaving today. We have movies and we have actors, but we don't have anything to link them yet. Luckily, there's this fun table called links, which does exactly that. And it's got the IMDb ID, which is kind of stripped of its TT prefix, and then some other IDs that, well, we don't care about TMDB right now, and movie ID we're going to use to join. So let's make a joined table. Say movies.join links on movie ID, because this is the movielens ID that we're joining on. Let's give that a better name. Let's call it linked movies. We can look at that. Okay, now we've got movies, and we basically can associate an IMDb ID with a set of genres, which is what we were after in the first place. So again, we've got movies. I'm just going to show the first row to avoid clobbering everything on the screen. We've got actors. And we've got our linked movies. Okay. So there's a piece of information missing here, which is the actors in a given movie, right? And I think what we're going to need to figure out there is which of these IMDb datasets actually contains that. And I think it's going to be in one of these CSVs, one of these compressed. Oh, whoops. Let's see what. Sorry, TSVs. Let's see. We pulled out actors. That was principals. I think we're going to want the basics. We're probably going to want title .basics.tsv.gz. We're going to look at, actually, let's call that titles instead. Right, so here we have a tconst associated with each title, and we probably want to filter out adult movies to keep this kid friendly. And cool, we've got that stuff. And now we actually can do what we wanted to do originally. So we've got our linked movies. And then, actually, let's see, do we have what we need? So we've got titles. So we've got linked movies, which shows that. Then we've got right, we've already done the join. We've got the genres per movie. Then we need to know, let's see, we've got actors. And it looks like, sorry, let me just refresh my memory what we're doing here. Right, so this is actually a list of each the actors in each movie. And so we don't actually have their names. So I think we're going to need to do another, let's call this actors. Let's just keep calling it actors. Sorry, let's call it titles actors. We'll call this actors. So we've got titles actors. And then we're going to need to know, I think, names of actors, which is going to be an ibis.read data ml parquet tsv. Let's let DuckDB handle it. Nullster is this thing, \n, empty quote, and here we go. So let's get actors, let's get actor names, and we'll call actor names titles. So we're going to do a names join titles actors, and we're going to join on nconst. And looks like that's big enough that it may take a little bit. Let's see. Well, that's fun. Oh, it looks like we have some spam going on in the chat. That's always fun. You're just trying to join some data sets. And looks like, let's see, do we have a tconst in here? Check that by looking at columns. Cool. So we've got actors, we've got the names of actors, the titles they've been in, and now we want to join that with our linked movies dataset, which has our genres. And what we're going to actually need to do is say actor names titles dot tconst, and then we're going to need to do a linked. So we're going to need to strip off the first two, tt, cast that to an integer, similar to what we did to the last time, and then we're going to equate that with linked movies dot imdb.id. This is going to give our actors genres table the right structure. And let's just look at this schema for now to make sure that it's kind of looking the way we want. So we've got primary name, which is going to be the actor's name. We've got title, which is going to be the movie title, and then we've got genres. So we can now see, this is probably going to take a second, so I'm going to try and get the first row in case that helps DuckDB show some more useful information. It's probably going to take a bit because we're doing decompression on, we're reading from the gzip file, so there's some I/O overhead there. It's text, then the gzip file has to be decompressed, and then the strings of the CSV file have to be parsed, and this is happening a couple of times. And because there's a number of CSVs, there's a few Parquet files in the mix, it's a little faster to do stuff with that. But it can still be a little bit slower than I think we'd all like in the interactive case. But in this case, it looks like, yeah, it took some time. And then what we probably want to do is say, actors equals actors. We want to group by, let's say, the primary name. And then we also want to group by the genre. Actually, what we probably want to do, and this is really going to slow it down, which is we want to say genres is equal to genres.split on pipe to turn this into an array so that we can then unnest. It looks like I used the wrong table. Ag genres or ag actors. Dot mutate genres. It's going to be, we'll just call it genre, and that'll be underscore dot genres dot split dot unNest. Okay, now we've got ag actors. So again, look at the schema. We've got our genre now, which is a string. And what we want to do is group by the primary name, which is the actor, the genre of the movie, and then we want to count. Now, this is probably going to take a while to compute, and it may error if I've written something incorrectly, but so far IBIS thinks this is legit. We can at least inspect the SQL to see if that looks sane, and I mean, it's going to be a huge SQL statement, but just kind of giving this a once over, it looks okay. So let's see actually how it goes. It's going to take a bit because of the joins and the reading of the CSV files, but again, it was this expression where we take our actors with their genres, split the genre, and then group by and then count. Of course, you can recreate it because it's cheap to do so. And then we probably, what we also want to do is maybe say ag, give this a name like n, and then now we can refer to it, order by n desk. Now we've sorted by let's see, we sorted by the number of rows, and let's see what happens here. Now this is going to take a while, so I'm gonna after I upload this, I'll probably edit out the runtime, but it's probably gonna take a bit. So all right, yeah, because this is probably going to be, there's going to be a lot of I/O happening and lots of inefficiencies in dealing with CSV files, which DuckDB is pretty good about it, but there's only so much you can do with text. Okay, so we've got a bunch of people that are at the top that are, looks like there's some, maybe I just don't know that much about movies, but Clarence Nash, known for animation. We've got John Wayne, known for westerns. Gerard Depardieu for dramas. Jackie Chan, action. Charlie Chaplin, comedy. Walt Disney for animation. I probably didn't do a great job of filtering out filtering in actors and actresses. But I think that concludes this video. If you want to know more, get involved. ibis-project.org. You can always check out the channel, cloudcomputing.live. And we are also on Twitter at ibisdata, all one word. Get in touch. Use the library. We'd love to hear from you. Thanks, everyone.